Hello, how are you doing?
I'm doing good. Just trying to make my area nice and everything and whatnot so I can actually be on camera today. Maybe.
Okay.
We'll see how this goes. If everyone doesn't come into my room constantly. I'm waiting on my brother to pop back in so then we can just have this on full screen.
Okay. Yeah, we'll start in a few minutes. How are you doing? I hope everybody's doing well. We'll start in a few minutes. Where we left off yesterday. Okay. Welcome. Some of you just joined us. Let me get some of my Python file open. Hi, Ghislaine. How are you?
Okay.
Hi, Cynthia. Good. It's pretty warm outside. Okay, so we'll start in a minute. We'll pick up where we left off yesterday, and hopefully we'll be able to get through some of the programming today with the circuit. So we'll pick up with assignment 1 in about a minute. Just waiting for everybody to kind of join us shortly. Okay, so it's 2 o'clock. I'll go ahead and get started. Yesterday we left off with finishing up some configuration for Raspberry Pi, and we are going to work on some of the Python programming today, along with building some circuit today using GPIO. So I want to kind of pick up where we left off. Um, do you have any question for me before we start? And then also I wanted to revisit VNC if some of you haven't had a chance to look at the video and set up your VNC. Okay, so I'll go ahead and share screen now. Let me get to the lab or the assignment. So we will pick up from where we left off yesterday, which is we talked about Raspberry Pi configuration in preferences. So you can do it this way, okay? So I mentioned that it's really important that we configure our keyboard to make sure that it's English US. You can always go back to that if you didn't configure that when you first start finishing your installation of Raspberry Pi OS. And we're using the Buster version, which is the latest version, and we are using the full version. So we want to set up our time zone with Los Angeles. And then, so for, let me stop share on this one and then let me share on the other one. Oh, okay. Oh, it's just giving me that. Okay, so here's my Raspberry Pi desktop. And a way that we can configure this is to use the terminal, which is located here. And so in terminal, if you do raspi config, um, but you have to use sudo for super user do. And so this will take you to the configuration. So this one, it doesn't have the capability in using your mouse. So when you use the Raspberry Pi configuration like this, you would just have to use your keyboard. And so a way that you can move up and down is to use the arrow key. So for your system options, if you need to add your wireless LAN, which is your Wi-Fi at home, you can set up this way, or you can also click the wireless icon on the top right. Okay. And if you click that, you will be able to add your wireless, or you can enter your SSID here. And then you will see that you would have other options here. So you can navigate to the lower options like select and back by using the arrow key or tab. So if I need to select, I can navigate to it using the arrow key left, right, or you can hit tab and it would let you do the same. And then, so I'm going to go back. So the difference between the Buster and Wheezy or Jessie, which are the prior versions of the Raspberry Pi operating system, is that they had changed up the first option and the interface actually for the configuration. So when you watch some earlier tutorial, this is a little bit different in that they had modified the menu from one version to the next. And then if you wanted to change localization, you can also navigate there, and you can change your time zone, your keyboard, just like how you would click here and go to your preferences. Okay. So when you choose preferences in Raspberry Pi configuration, you would see that will be the same as this. So in the exercise, it have you set up your wireless LAN, which is part of the first option. And then you can just enter your SSID and your passphrase. and then select enter. So I'm going to go ahead and go here, and then I'm going to get to finish. Okay, so now I'm back to the terminal, and so we talked about how we can check our Python version, and we touch on Python. If you type in Python dash dash version, and this is the same for Windows and also Mac OS as well. When you're using Windows command prompt or Mac OS terminal, they also call it terminal. It looks very much like this. You can also see the version. Now Mac OS comes equipped with Python 2.7 as well, along with many Linux releases. For Microsoft, you have to install. And so we touch on how we would do sudo apt-get update. So whenever you're getting ready to install any kind of software on Raspberry Pi, you need to make sure that you update your Raspberry Pi, even though you have probably just done so maybe 30 minutes ago or yesterday. Okay. And so I would see here that, let me expand this. That it now show me that I'm updating the Debian Buster version, which is the Raspberry Pi or Raspbian, the operating system. Okay. And then if I need to install pip, I just simply do sudo apt-get install Python 3 pip. Now, if you just do a Python pip, it will automatically default to the 2.7 version. So you have to tell it that it has to be Python 3. And so with that, it would say, okay, it's unable to locate pip. So when you see this kind of message, what you can also do is you can do sudo apt-get pip or look up the information on how to get pip. Now, when we move forward and we would say, okay, we want to first maybe install apt install Python 3. And with that, we need to tell it to install idle 3. So the Python 2.7 comes with its idle, which is the interface where you would use the editor to write your script and run your script. When you want to install Python 3, you want to also tell it to install idle 3. Now in Microsoft, if you use just your Windows environment to install Python 3, when you would have to use pip 3 or Python pip. So you have to update your pip in command prompt and then install Python 3. And with that, it will come with idle. You don't have to specify idle 3. Okay. So it tells me that it already put in the idle and the Python 3 in my Raspberry Pi. And then it also updated that Python color 0 is no longer there. And if you ever wanted to remove something, you can also do sudo apt auto remove, and it tells you how to do that there. Okay. So on the last line, it's usually just tell you how you can upgrade. So with this class is you're going to see that we are going to use a lot of Linux terminal. And this is the best way that you can work with Linux because there are a lot of things that we can do in terminal without having to click like 6 steps to get there. Most of the stuff that you see on GitHub or Git can automatically be pulled in the terminal by using, apt install or install command. So now if you're using another version of Linux, you have to use, like, if let's say Fedora, it's a little bit different, or Red Hat, it's a little bit different as far as command goes. But Ubuntu or Debian base, you would see that we would use like sudo apt-get or sudo apt-get install. So when you do the apt-get, basically you're just pulling the actual installation file, and then you have to tell it to install. So you have to do the apt install. Okay. And so once we already have the installation done with Python 3 and idle 3, it might take a few minutes on yours. If you haven't installed it before, then you can call on Python 3. Now, if you just issue Python, again, it's going to go to the 2.7. But if you call Python 3, then you have to say Python 3 and then press enter. And now what you see is you are in shell mode. So when you see the arrows like this, that means that you're in shell. So just like how you would open up IDLE, which is its IDE, and IDE stands for Integrated Development Environment. It's a way that we can write our script and run our script. Um, so what happens is the shell is used as an interactive tool with Python. We can write each line of our script directly into it. So if I wanted to print, which it's basically going to display text, and text is known as string in programming. So we can say hello. Let me move my mouse here. Friends. Okay. And for string, you want to enclose it by the quotation mark, just like how you would use string in C, C++, or Java. Um, and also in JavaScript. So when you issue it like this, it automatically would just interpret that line and give you the text that you put in the quotation mark. So if I wanted to make my string longer, I can go ahead and do so, but make sure that. And Python, you don't have to use double quotation mark. You can use single quotation mark. Most of the people in the industry would use single quotation mark versus double quotation mark. I just keep it double quotation mark because, if you're familiar with other programming language, it's just easier for you to remember. So it works with both. Okay. So at this point, we interact with the shell in Python, and we simply call on Python in order to do the shell. Now, can you write the whole program line by line like this? Sure, you can. But you in shell, you have to execute each line. So as you write each line, you have to press enter. And then in the case of a loop, when you enter the loop, like for example, a for loop, it would also wait for you to finish. So um, and I really enjoy writing in Python because it's easy, it's user friendly. There are tons of libraries that you can use. And if you look at the type of jobs, it's used in web development, in application development, in data analysis, so many different things. So the point in this is you can definitely use your Raspberry Pi to practice Python. Um, because Raspberry Pi is designed to have a lot of tools that will work with Python. Okay. Now, if you don't want to do line by line like this, you can use the default text editor, which is Nano. Nano also exists in Mac OS, and Nano is equivalent to Notepad in Windows, in that you can use any editor really to really write your Python file. As long as you save it as a .py, you're able to execute it, and you can even execute it inside the terminal itself. So for many administrators, system administrator, database administrator, that work on Linux systems, and you would see that Linux is being used for web server quite a bit. So all they need is really the terminal, and so that way they can get around it. So in step 41, we would then issue the exit method, and method is equivalent to function in C or C++. So when you use the method, you just have to have the parentheses with the actual function or method name. So, and this is built in. So when you issue exit, it automatically knows that you want to exit out of shell, and it brings you back to your regular terminal. Okay. So now you can see how that's done in the terminal. Next, we are going to open up idle. So once you have the idle and idle 3 and Python 3 installed, it's going to put that in the programming menu or drop down menu from your Raspberry Pi button. So this is like your start button on the top. So here's the programming. And you would see that there are all these programming tools like Mathematica, right? Wolfram Engine. So with the full version, you will get more of these tools. And then if you wanted to learn logic gates, you can do, I think it comes with like a sim. Um, and also there are other IDE here. Okay. I use Tawny quite a bit. It's a light IDE that I don't normally use for my Python class, but you can definitely use Genie, and Genie can be used to write anything that will be C based. But Python packages is linked to this one. So we would then go ahead and choose our idle for Python 3. This is the default IDE that comes with the Python packages that we install. And I previously mentioned in the last session that you start seeing the shell first. And when you use the idle, you need to really look at the version that you're using. So here it tells me that I'm using 3.7.3, and this is a stable version. So um, there are 3.9.x that are available. So now in order to really write your actual script, you would click File, New File, okay? And so what happens is when we open the new file, it takes us into what's called the text editor of the IDE. So there are two parts to idle. There is the shell, which is what you see first, and then there is the text editor, which is what you would use to write your script. And in shell, you can do something like 2 times 8, and it would calculate that for you, right? There are a lot of like really easy, simple things that you can do. But if we want to write a Python file, we would then start with this. And Python, it doesn't require, it's not a truly strongly typed language. It is a typed language, but it is flexible in that it would automatically know what type of data you're using when you create your variable and how you declare your variable. What do I mean by that? So if I say my name is, right? So I say my name equal, mean is, right? And then I put Casey Win in quotation mark. It would know by doing this, its type is going to be string because it sees that I put in the quotation mark around the text. So now when we do this, that means we declare a variable, and that variable is going to contain a string, and the string that I use is my name, Casey Wynn. And so you can put in your name for that one. And then on the next line, we can simply just use the print method. And as in any method, we need to have the parentheses, and we would then pass the variable that we previously declared, right? We say that my name is this, and I want for it to print out my name. Then after we finish writing our script, we would then go File, Save As, and then you can say like name.py, or I already have one like that, so I'm going to say name1.py. So we would know that it's a Python file by giving it the Python extension. We're going to click Save. Now, once you have your file ready to go, you can then click Run or press F5. Okay, so run and then run module. Okay, so as you notice that once I choose run and run module or press F5, it shows the output in the actual shell. Okay, other IDE, they would have both of these together, like either this at the top or this at the bottom, or side by side, so you don't have to flip between the window. But for idle, this is the way it looks. So your output is always going to be in shell, and the way that you write your program is always going to be in the editor, which is part of the idle itself. Okay. All right, any question with this? Okay. So that kind of give you a little bit of the basic in how to use idle and just write the script for your Python using Python 3 and then run it. Okay. All right. So for the next part, what we're going to do is we are going to work on exercise B, in that we are going to use LED. So you are going to need your Raspberry Pi with the power cable, a breadboard, um, light emitting diodes, and resistors, female to male jumper wire. Okay. Oh, also before I forgot to show you how to do VNC. Okay, before I start, if you didn't get a chance to watch the video, um, VNC is a way. Let me stop share on this one real quick. And then I'm going to switch to this one so I can show you. VNC is a way that we can remote into the actual device, so you can use it for your Raspberry Pi or others, etc. So all you have to do is you can Google VNC Viewer, okay? And some of you have used like Team Viewer and stuff before, but Team Viewer is unstable. So you would find Real VNC release the VNC viewer, okay? So now you can download it for any operating system that you have on your computer. So let's say I'm on my laptop right now and I need to connect to my Raspberry Pi, um, you know, and I wanted to be able to configure it from my laptop instead of, you plugging in the monitor, the mouse, and the keyboard. Um, So I would then download the VNC viewer. And when I click this, because it sees I'm running Windows 10, so it's going to give me the executable, and then I would just install it. So if you're using Mac OS, you would then choose this option, or if you're using an iPad, you would choose this option, or if you're using an Android, you would choose this option. Excuse me. So once you click this, you would have an executable, and then run that executable to install, and it's going to load the MSI, which is the installation file format for Windows if you have Windows PC. If you have Mac OS, Mac OS automatically, once you have downloaded that package, what it will do is it's going to let you add it to your applications, and then you just click yes to add it to application folder, and it would then be able to, you can use it. Okay. So the first step is to download the VNC viewer for your system, the system that you are going to use to access your Raspberry Pi. Then the second step to this is to, hold on, I just want to make sure that I can. That you would then find the IP address of your Raspberry Pi. Okay. So what do you need to do that? You can find it in terminal, and you can just do ifconfig. Okay. And on Linux, it's the same across for all Linux. Some Linux, you have to install the network packages in order to use ifconfig. You can also use show IP address. Um, that will also work as well. But ifconfig will give you the IP that you would need. So here, what you would see is you would see um, your Ethernet adapter MAC address information. But what do you really need to look for? The IP address is going to be what's called the INET. Okay, and I'm not seeing it. So if you look for the INET, there's the INET 6, and then there's the INET regularly. So when I'm looking at this, I would then be able to locate my iNet address, and that way it would be able to, I would be able to use that. So once I have the IP address, I would come back to my VNC viewer. Okay. So once I install it, it's here. And you notice I already connected. So you can go File, New Connection, and then put in the IP address that for your Raspberry Pi, and then you can give it a name. So as you see, I named mine Raspberry Pi 4, but you can call it, whatever you like there. And so once you do that, then you can click OK and it will connect. Okay, so to prove that to you, I'm gonna go, hopefully I can. Okay, so this might take a second. And you can also configure your Raspberry Pi display settings so it will be, better in the resolution or other things. But the tutorial video that I linked, Diana Dunn, she actually goes through and she showed that too. So it's timing out on this. So you can go ahead and also create a new connection, put in your IP, put in your identifier. You don't need to nest any kind of label or anything like that, and then click OK, and it should work. I'm gonna do that actually. Okay, so now you would know how to use the VNC viewer. Okay, so coming back to what we were talking about, we were talking about this part here. We are going to work on exercise B. So you would need an LED, any color. I think on mine, I chose blue. So if you have multicolor set of LEDs, you can choose blue, red. Blue and red are easier to really see, especially if it's dim. But you can definitely use the other color as well. So this one is going to be 2-prong. Okay, so it will be like that. You're going to need a breadboard, and this is a breadboard. And then you are going to need 2 jumper wires. So this is a jumper wire. Okay. And in Raspberry Pi, we're going to use male to female because the female end is going to go on the GPIO, which is the 40 pin on the Pi. Okay. So after you have the equipment ready, then you can plug in your LED. The long leg is going to be on the right side. That's showing a little curly leg like this. So when the diagram shows like this, that will be the long leg. Okay. And then your shorter leg is going to be on the left. And for electronics components that we are using in this class, when you are connecting to the breadboard, as long as you are having the direct line connecting to the wire, it should be able to transmit the signal down that path. So you want to connect your jumper wire, the male end, the one with the pin here, and then you would then connect the female to the GPIO. Okay. Now for the resistors are going to be these right here with the stripes. And in my last class, I have mentioned this, but you can also find resistor coding. Let me see if I can find it and put it in the chat for you. You can also search for resistor color code. And there are many different type of charts online. Okay. You can also find calculator and other things online too. So how are you supposed to read which is which, because they look very similar? Okay. So the site that I gave you, and not all manufacturer will follow the standard, but in general, you're going to see something like this. Okay. So your resistor, the background color might be blue or tan or some other color, but the bands are going to be important. Okay. So if you're looking for 220, you're going to see red, right? And then the multiplier is going to be 10, which is going to be brown. If I'm looking for 320, that's going to be orange. So it's going to be 330, I'm sorry, orange, and then brown. Okay. So if I'm looking for 3,330, that will be orange, and red. Okay, because the multiplier is going to be 100. So here it shows you how you can read the resistor. Now in our exercise, you just need to line up one of the leg, and it doesn't matter which end you plug it in, it's the same. Okay, you can plug it in either way. Line up one of the leg to the shorter leg of, you can put it next to it, or you can put, a few spot down, that will be okay with the shorter leg of your LED. And then we're going to line up the wire for the other one with the other leg of the resistor. Okay. Then you are going to connect it to your Raspberry Pi. You can follow the exact location, but like I mentioned, the card that you see in your box, like this card, okay, the Cana kit, there's a rectangular card that has the GPIO information on it. You can refer to that to see exactly what pin you're plugging in. So based on the diagram that we're seeing, okay, the green connection here, that's gonna go to your ground, and it has multiple places for ground on the Raspberry Pi. And then your yellow wire, or the second wire, that's going to go to GPIO 18. Okay. And so when we plug that in, you just count the pins on your Raspberry Pi. So when you plug in the top part with the fan, you just got to give it the 5 volt or the 3.3 volt and the ground. Okay. Any question? Okay, so once we plug that in, we are going to install the RPI GIO on our Raspberry Pi. So let me stop sharing this. And I'm going to switch over to the other one. Okay. So now what we have is we have the terminal here. And what we're going to do next is we are going, after we plug in our circuit, right, from our breadboard to our Pi, we are going to put in sudo app get update again. Okay, because we are getting ready to install new packages. So then we're gonna do sudo app get install our pi.gpio. Okay, so you need to bring in this library into your Raspberry Pi, and that's what we're doing. Without this library, you will not be able to have the blinks for the LED. Okay. Yeah, so my screen is a little laggy because it's just Raspberry Pi connecting to the network. It's not always the same as the other system. So, okay. So once you have that ready, then what you will do next is you are going to open up your idle 3. So we're going to come back over here and we are going to go to programming, and then we are going to open up idle 3. And in idle, we would then click file, new file, and we will start writing our program. Okay. I have it written, so let me open it. Okay, so now the important thing about Python is that when you see indentation, you need to tap in and make sure you indent that line. Okay, so as we are writing this program, I'm going to explain what the code means. Okay, there are places like in the try, except, and finally, you will need to have indentation following the colon. Any question? Okay, so we install the library in our Raspberry Pi. So in any kind of system, okay, when you are using libraries, which are files that have been created by other people, other programmer, developer, scientists, etc., and you're pulling it, in Linux, you just simply do apt-get and it's going to pull it. And then if you issue install, it's going to install it for you. But in Windows environment, we have to do pip install, and then we would then have to import in that library. So first you would then install the library to the device, okay? Then when you write your program file or your script, you need to make sure that you are importing in the components inside that library, okay? Because that library can be very large, but we're only going to use some of it. So in this script, what we're doing is we are going to import in the time module, and basically that's just going to bring in the file that we need pertaining to time, because there are certain things here that we're going to use that's going to tie to that module. Okay. Then we are going to import our Pi GPIO, this module, and we are going to give it an identifier. We're going to call it GPIO. So the way Python works is you can bring in the module, and then you can label it, use a label for that module as something else. And that's going to be the name that you're going to use throughout your program. So compare this to C or C++, it's like doing include, but C++, usually you just include the actual library or the file itself, right? Like a .h, you see that in some of the Arduino project if you took that class. So Python is a little different in that we can also give it a name as we bring that in. And that's the name that we're going to use in our code, in our script. So we are going to define our variable. Okay. So, and when we do running here, we are going to use running. And running is just a name that we give to a memory location that's going to store something. And in this case, we're going to store a Boolean value that is true. And when the computer, when Raspberry Pi see that, it's going to say true is equal to 1 digital, right? So this is a bool type. So we are saying basically here we're declaring the global variables, okay? And in C, you would have to say const, right? Or I'm saying bool, right? Running equal true. But in Python, we simply just do running is the name of it and true is the value. Then for the next variable, we're going to call it LED. And here is where you're going to define or declare, assign the value that's going to be equivalent to the pin that you connected. So earlier, if you recall, we connected to pin 18 on the Raspberry Pi. Then here is where we would say 18. So if you connect it to pin 16, you have to put 16 here. Okay. Then after you declare the variable, then you need to set up your output mode. And in these, what all it is just going to be how we want it to be output. In out is it's going to show, it's going to light. Okay. Very similar to what you see in your Arduino. Okay. So as we give the module the label earlier GPIO, you are going to use it with its method or function from the library. So think of it like a command in Arduino. Okay, it's already built in that particular library, so you're just pulling it from that library and you are going to use it. Okay. So here it tells you, here's the comment, and we use hashtag in Python for comment, and the interpreter would ignore this line because it's not going to be as of important. We put a hash in front of it. The hashtag allows us to use that as a comment. So it tells you that we are configuring the pin, right? And we are going to use BCM scheme to set the pins for the output mode. So what we want to do is we are going to output from the from pin 18, okay, which is connected to your LED on the breadboard through the wire. Okay, so first we have to set mode, and we are going to tell it to set mode for BCM, and then we are going to set up, okay, kind of like pin mode in Arduino. So here we're going to do a setup, and then we're going to pass the LED variable, which is going to be pin 18, and we want to output from that pin. So we would do a GPIO out. And as human, we want some kind of verification that this has been done. So as soon as it finished doing that, it's going to output the text in the shell, let the flash begin. Okay. And then we are going to print, press Ctrl and C to quit. So what's going to happen is we're going to have to write the script that's going to allow us to the Raspberry Pi to stop the program when Ctrl+C is pressed on the keyboard. Okay. So in the main, and Python doesn't require, there is a main location, it just, we don't need to label it main. So this is the main area of your script. So here we are going to handle the exception. And exception can be error, or exception can be used for interrupt, right? We talked a little bit about interrupt in embedded system yesterday. So what would be an interrupt? We're running the script, it's blinking the light, and we want to press Ctrl+C on the keyboard to interrupt the process, to stop it. Okay, so we have to write the instruction for the system to be able to see that. And so in exception is anything that's outside of its normal behavior. Okay, so it could be a logic error, it could be some kind of error, or it could be an interrupt. Okay, and sometime in my Python class, I showed this in input validation. So you can use it for many different areas. Okay, so we're going to handle the exception, and we are going to use Python format in that form in that we're going to use try and except. So whenever that you use try, you should always have the except to follow. Okay, so this is very, very similar to catch, try and catch with C and C++. Okay, so we're gonna try, so it's gonna attempt this area, right? And then if in any circumstance that it sees the Ctrl+C, it's gonna execute this part. Okay, so basically we're saying try while true, running is true, right? It's gonna output to pin 13, and it's gonna give it full voltage, high. It's gonna wait 0.25 seconds. So we're gonna do the time sleep here. It's like sleep in Arduino, right? So we have to bring in the time module in order to do sleep with Python, with Raspberry Pi. So you are gonna wait a quarter of a second. Then we are gonna turn it off at pin 18. And then wait again for 0.25 seconds. Okay. So it's gonna keep doing that forever if you don't press Ctrl+C. Okay. But in the case that it sees the keyboard interrupt, so in the except, it's gonna wait for the keyboard interrupt. If there is a keyboard interrupt, it's gonna stop running. So it's gonna plug the false into the while loop, and it's gonna exit the loop. Okay. And then it's gonna show you quitting. Any question? Sorry, I can't. I thought there was a chat question, but there's not. Okay, so you have to type that into your editor. Okay, just make sure that you look for, if you run it, so you plug in your circuit, then you write your script, then you run your script. If it's not working, if idle is showing you the error, you're gonna go to that line and see maybe there's a typo. But if it doesn't show any kind of error, then you should see flashing light. If you don't see flashing light, that means you're plugging into the wrong pin. So check your circuit. Okay, so I'm gonna go ahead and run my module again. And then I'm gonna switch stop share, switch camera. Okay, you see my LED? So it should be blinking like that. And the way that you connect it, you make sure that you follow the diagram. And then on the Raspberry Pi, okay, you can leave your Pi running and plug it in, write your script, run your script, and check to see if it's working. If it is working, take a picture of it, and you're going to use that for assignment submission. Okay. I don't know if you know, but Canvas has an app. It's called Canvas Student. So if you wanted to access the assignment from your phone and upload the picture, that will be easier than having to transfer the picture from your phone to your computer and upload it. Okay. So GPIO, we're gonna plug the female in on that, and then we connect our circuit. Okay. And then we write our script. Then we run our script, and we should see flashing LED. Any question? Okay. And you can test this. So on your shell, you should see let the flashing begin. Press Ctrl+C to quit. So I'm gonna try to press Ctrl+C. Okay. And I want to show you that works. And oops, sorry. I'm trying to switch camera and it's okay. So my LED stopped blinking. And then the output for that is, it shows me that it's quitting. See that? Okay. So now you already know how to write. So in this exercise, what we're really learning, right? We learn how to control an LED through GPIO using Raspberry Pi through Python script. We also, in that Python script, we learn how to handle exception in the case of keyboard interrupt. Okay, and with that, we also see how a while loop is written. While loop, it will keep on running as long as the condition is true, running is true. But in the case that when it receives the interrupt, it changes the condition to false and it's going to exit that loop, so it stops. Okay. Okay, any question with exercise B? Okay. And I didn't mention this, but for the last part, finally is always going to occur. So when you see the finally statement here and the task that comes with finally, so after it quits, it's going to go to the finally. And so normally you would see these type of statement being used in Python. So you would have try and accept. You don't have to add finally, but if you want something to execute after the exception handling anyway, regardless, then you would write a finally statement. And what we want to do is we want to do GPIO cleanup. That means that it's gonna clear for the GPIO, which is really an object that it brought in from the library. Okay. And so, yeah, my class for Python, they just went over, or they're going through exception handling, and this is something that you can, it's a good example on how you can use, try and accept to handle things that would occur outside of the norm. An event, it could be an error, or it could be an interrupt. Okay, so we have it clean up at the end, and you want to do that, right? So after you can also execute your Python file from your terminal instead of doing the F5 through idle. Okay, so if you do sudo Python and the name of your file, it would execute. So here it talks about, running it for a fourth of a second, turn off, for a fourth of a second, repeats until Ctrl+C is pressed. Any question? Okay, no question. All right, next I'm going to go over exercise C, in that we are going to use RGB. I have a chat question. Is RPi GPIO or GPIO 0 better? I like using our RPi GPIO. You're gonna have the same thing, but GPIO 0 is really written for Raspberry Pi 0W, which is a smaller Raspberry Pi. And in the Raspberry Pi 0, you have to adapt, or you can solder in the GPIO or insert it. It doesn't come equipped, and there are less GPIO on the Pi 0. So that means you just have less pins. Mhm. It still works if you're using the common pins. Okay, yeah, you're gonna have similar methods, and from those modules, it's just there's some slight difference. So on the regular Raspberry Pi 4 or 3, you should use the RPi GPIO, right? On the smaller Raspberry Pi like Pi 0W, you can use the GPIO 0. Other questions? So for the program, I forgot to mention, you don't have to put comments if you don't want to. I normally add the comments so that way I know what's going on in the script. But if you don't want to type that out because it could be tedious, okay, that's fine. Okay, so next we're going to do the exercise C. And for the exercise C, and if we finish this one, we will also move on to, we would start the lab so you don't have to do so much tomorrow. I don't know why Zoom doesn't let me see. Okay. So Albert, the important part is to find your Raspberry Pi IP address. If you don't know its IP address, you should look into your wireless router. Your wireless router lists all the devices, and it will tell you what IP address that is. If not, you need to connect it to a mouse and keyboard and then go to terminal and be able to do that. Then once you have the IP address, then you can use the IP address on the VNC viewer. Okay. Without that, the Raspberry Pi IP address, you will not be able to use it. So, and also for the rest of you, your Raspberry Pi, if you use the default setting on your wireless router, it will renew IP address periodically because it's a lease. it's using dynamic host control protocol, which leaves this IP address every so often, right? Depending on your router settings. Sometimes, 3 weeks, a month, 3 months, etc. So if you use that same IP address, over time, it might not work. That's what I'm saying. Just make sure that you check its IP address. Okay, ifconfig in the Raspberry Pi, or if you don't have access to a mouse, keyboard, and monitor to plug your Raspberry Pi in, you can, log into your wireless router and look at the device listing. It lists the MAC address and the IP in the wireless router. Do we need the Pi to give permission to our computer to allow? No, by default, no, Kevin. You can, so there are two ways to remote connect. You can use VNC. Oh, you're correct. I forgot to mention this earlier. Thank you for bringing that up. You can SSH in, but you have to enable VNC. I completely forgot about that. It will not work without it. Okay, 1 second. I will share screen. Okay, so earlier we talked about how you would go into the Raspi config. Okay. Okay, like this. So I just simply do sudo raspi-config. And what you want to do is you're going to go down to the third option, which is interface options. Okay. And you can click and point on the preferences menu options as well. So for the interface options, you will find P3, which is VNC, and you have to enable it. By default, it's not enabled. Yeah, your this class would only work if you have your Raspberry Pi connected. So if you need some help at the end, see me at the end of class. I'll help you out. So you need to access your wireless router to get your Raspberry Pi, or plug it into, if you have a mouse and keyboard, you can plug it in with your TV and then get its IP address. Okay. So for the Raspberry Pi, you have to enable VNC. Otherwise, it does not work. Okay. So you see the P3 option, which is VNC. Okay. You are going to select that, and then you have to say yes, you would like for VNC server to be enabled. The way that it works is the Raspberry Pi is going to be the VNC server, and your computer is going to be VNC client or the viewer. And that's how it's going to talk. Okay. It's not a hard class. It's just once you have access, it's good. So once you enable it, you say yes that you want the VNC to be the server, it would then be okay. Okay, so pick, if you see my screen there, you would pick option P3 and then choose yes for VNC server and then say okay. Oh, yeah. So for the screen setting in the configuration, it's going to be option 2. So I'm going to, yeah, it's there's a little delay. I'm like 5 tasks ahead of this and your screen is showing like those things. So display options, or you can click the Raspberry Pi, go to preferences, Raspberry Pi config, and then there's a display tab. But let me see. Yeah, option 2 on the Raspberry Pi config using terminal, and then you can change the resolution to a specific screen size by choosing D1. Okay, so now that you're able to see a little bit on how you would enable VNC, use VNC viewer, and then also change your display options. Yeah, sorry, Raspberry Pi doesn't have a lot of RAM for video, so when I'm screen sharing, it's a little slow. Okay. Any other questions before we get into RGB? We have a lot of time left, so. Just the initial part is hard. All right. So this is how you can change. And then once you select your resolution, right, you can go to, small or large size. So if you want 1280 by 720, or I think 1920 by 1080 is generally good for most monitor. So that will be, or, depending on the size that you want. Okay. All right. So once you select it, just do OK and then finish. Okay. All right. So slow. It's not even showing what I was selecting earlier, but. And you saw what happened with mine. It occasionally time out, so you have to reestablish the connection. It does that for security reasons too, the way that they write the application. It's not going to be on forever. Okay, let's talk about exercise C. So on this one, we are going to use the 4-leg LED, which is known as the node RGB LED. R stands for red, G stands for green, and B stands for blue. Okay. And so for the RGB LED, this can be either be a cathode or an anode. Most of the ones that you find in the common, in the market, it's going to be the anode. Okay. So that means that you would need to have registers being used for each of the leg. And so this is another exercise that they use with Pi 3. But the RGB would be like this. This would be the picture, okay? So when you look at the RGB LED, the one on the left is going to be red and the longest leg is going to be ground. Using the iNet from ifconfig doesn't seem to work. So you enable VNC on the Pi, click VNC icon on the toolbar next to the Bluetooth symbol. it will bring up the screen on the left and tell you IP address to enter. Okay, your computer when setting up new connection. Yeah, that will work too, Kevin. Thank you. Okay. So it's like this. So make sure that you enable VNC. And then on your top right, once you enable it, it will be this right here. Okay, it should say server, and then you can connect. Yeah, so when you're looking at your iNet, your iNet, your iNet address, make sure you're looking at the right one. The 127.0.0 is not it. That's a loopback. Some of, you know, if you're using sometime iNet 6, don't use iNet 6, use the version 4, which is just regular iNet. Okay. Yeah, it should work if you're on the same network. Okay, so Kevin put in some tip there. All right. So for your RGB, as I was saying, the red is going to be this left leg, and then the ground is going to be the longest leg, right? And then G is going to be the green here, and then blue. Okay, so red, green, and blue. And the longest one is going to be ground. So when you install it, you want to spread it out a little bit so that way you can fit it, you can insert it onto your breadboard. Okay, so one goes into each of the hole. And so your ground, the way this is connected is that it's going to go from here to the channel for the ground. And then from this, we're going to connect it to the actual ground, which is the third pin on the right on the GPIO. And you can use the color scheme like what they use, or just remember which one. So this is the most outer one on the left. That's your red. So red is going to go to this pin. And if you look at your GPIO chart, right, or your code, it will tell you which pin that is. Okay. So that's going to be 17. And then next to it, wait, yeah, that will be 27. And then here is going to be the one across from 17. That's going to be 18. Okay, so it's 17, 18, 19, 20, but they label it 27 on this. Okay. So once you connect everything together, let me hook up mine real quick. Okay. Then you can go and once you set everything up, then you can open up your idle 3, right? So if you did the last exercise just now, you don't have to do the update in the RP or GPIO, okay? If you haven't done that in the last exercise, you need to do these two in the terminal. So after that, we are going to write our script. Open that up. Okay, so I'm going to show you how it's supposed to output and I'll explain the script. Okay, so it's supposed to flash and change color. I know my camera doesn't do it justice. You see how now it's changing to like a pink and then it's going to go into like other color. Okay. And the way that you connect it is each of the resistor needs to line up to the red, the blue, and the green leg. Okay, the only one that's going to line up to the wire right next to it is the ground leg, the longest one, the second leg. Okay. So when you start, you're gonna have the red is gonna be on the left side, and then next to it is gonna be the ground, which is the longest leg, and then the green and the blue. So each of your resistor is going to line up with the red, the green, and the blue. You're going to skip the second leg and plug the wire next to it. Then the other wires is going to follow and it's going to be adjacent to your resistor. Then since you're bridging the ground, you are going to have to connect that ground to your Raspberry Pi. Okay, so follow the schematic on the handout and you should be good. And this will only flash once you run the script. Also on the shell, when you run the script, this is what's going to happen. You are going to see like 0 and 1s for red, green, and blue. And then it's going to say light it up and it's going to show 0 and 1s. Okay. As it runs. Sorry. Okay. Any question? Okay. So in order for this to work, you need to install GPIO. Just like what we did before. And before we install any packages, we got to update our Pi. Okay. Once you install it, then you're going to import that in. So we can do import. And in this one, we're going to do random and time. And since we install the GPIO, we're going to do import our Pi GPIO as GPIO, just like the last one. Okay, you're going to see similarity with this. So next, we are going to declare the variables that's going to represent the pin numbers on your LED. Okay. So there's a variable called running, and that's going to be true. And we are going to set mode for GPIO BCM. We have to do this before we have it output, just like the last one. Then we're going to have red is going to be pin 17. So the pin that you're connecting it to, you have to specify that here. The green is next to it, that's going to be 18, and the blue is 27. And if you are not sure, you can look at the card, right, that comes with your kit, or you can use a chart that's online for Raspberry Pi GPIO. So once we have specified or set the pin up, then we need to make sure that it's going to output. So we are going to use the setup method in GPIO module, and we're going to tell that for pin 17, it's going to output. 18, it's going to output, and pin 27, it's going to output. So one for each color. And in this one, we also use RFEQ or freq, right, for as a variable to hold the value for frequency. And this is the value in hertz. So we comment this and we would say that it's hertz. So if you want, and on average, you would see that it's about between, 60 to 100 or 50 to 100 is generally okay, right? So if you wanted higher frequency, you can go higher. Then we are going to set up the LED color to start and how we want it to go to switch it on and off. Okay, for the cycle. It's called duty cycle. And you need to know that it uses pulse width modulation, right, in order to give you the color as it outputs. So for the red, we want to define red. That's going to be pulse width modulation for red with frequency of 100 hertz. We're going to start it at 0. So when you're looking at your output on the screen after you run the script, you're going to see how it's using, the 0 and 1. So it's going to start with a certain value and it's going to cycle through. Okay. So it will give you like 101, 001, and so on. So we're going to start with red off. Then we're gonna also have green, the same frequency with pulse width modulation, start with it's off first. And then blue, same, and start with off first. Then we're gonna change the color. Okay. And we are gonna use change duty cycle. This is a method that's written in the module. So that way we can have the light turning on and off for different color. So here we write a function called color, and we're going to pass red, green, and blue with on time. Next, we are going to have it for how intense you want to be with the color. So that's going to change it up. As it lights up, you're going to see that it's going to be brighter, 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 and then it switch off to another color. Okay, and that's what we're doing here. Red, green, blue, and then it's going to sleep. That's a short time and it's going to change. Okay, so as it reaches a certain brightness from 0 to 100, then it's going to turn off. Okay, for each of the color, so that way it switches. And on your shell, it's going to start to display, light it up. And then you also have Ctrl+C to quit. And then it's going to print RGB. So it's going to show you the 0 and the 1's value. So that way you can actually see the pulse width modulation value that's as it changes the color. Okay, on your shell. And very similar to the last one, you're going to have exception handling here for the keyboard interrupt, which is Ctrl+C. While it's running or true. And in this one, we're using nested for loop. And we're using for range loop, actually. Okay. And the way Python is, you write the for loop, you just say for x, that's going to be just a variable. that's going to represent each of the value in that range. And we would say for X in range, the value that you start to the value that you want to finish in that range. So for X in range of 0 to 2, Y in range of 0 to 2, Z in range of 0 to 2. You're going to print X, Y, Z. Okay, that's going to give you, the ones and the 0 that you see. And we are going to use another for loop. So make sure that we indent, indent, indent. Okay. And then another for loop, we're going to access the range from 0 to 101. That's going to give you the intensity for the percentage in your color. Okay. So we are going to take X times Y, Y times I, and Z times I. Okay. So that's going to be your color mix. How it goes from really light blue to really intense blue. And then once it see a keyboard interrupt, it's gonna plug in the false into the while loop and exit out of the loop, and it's gonna quit. Okay. And then for finally, we just want to make sure that it cleans up the GPIO at the end. So that's important, right? So in the case where anytime you use GPIO, you bring in the module, right? Whatever you name, since we name it GPIO, we wanted to use that object with the method to make sure we clean it up. So this one is slightly different than the other one in that we have 3 colors to deal with. And since it's, multiple color, we would have to implement the for loop nested in the while. And then we wanted to change the intensity of the color using the percentage. So that's how you write that. Do you have any question for me as far as the script? Okay, so when you plug it in, spread out the leg for the RGB and make sure that you follow the schematic that's provided to you. And then, you can leave your Raspberry Pi on when you're plugging it in, write your script, run your script, look at your shell to see the output, and look at your LED. If it's not flashing, then possibly that you plug into the wrong pin, okay? Or, maybe your LED is flipped around somehow. It's not having the right connection. Okay, and then if your idle is throwing error, check your syntax. There's a typo or anything, but on idle, it kind of indents it automatically indent for some of the things. But when it's indented in the code showing here, make sure that you indent it on your code or your script. Any question? So tomorrow, I'll preview some of that today. We're going to use the piezo, which is the buzzer. And we're going to play Star Wars. But unlike the Arduino exercises or a lot of the exercise you see on the internet, we're not going to write it. We're going to actually take someone's script and run it. Okay. So it's going to pull it from a Git account. Open source is great in that, like, if somebody already did the work for you, why do you have to redo it, right? So I wanted to show you how you can use your terminal to pull stuff and then to be able to utilize it, just to streamline the process and save time. Okay, any question? Any issues with your circuit or any question? Okay, so once you have your light flashing, just take a picture of it, okay? And then you can use it for assignment submission. Yeah, sometimes if the JPEG is very large, or if your files are very large, Canvas won't take it. So, but in general, it should take a lot of the images. Okay. Oh, yeah, you only if you're using VNC, you don't have to enable SSH. If you use SSH, then you can enable SSH. So SSH is more secure, but the application that uses SSH, like Putty and other program, the window might be limited in that it's smaller. Okay. Yeah, it's always going to say that. So SSH is more secure. So down the line, if you frequently use your Raspberry Pi, then you should use SSH. But for right now, I'm okay with you using VNC. And for the rest of for everyone, when you're not using your Raspberry Pi, turn it off. Okay, because when you start adding all of these elements in, and if you're not securing your Raspberry Pi, it's just another vulnerability on your network. So when you're not using it, just turn it off. Okay. And plus it runs really hot if you leave it on the whole day anyway. So some people, they use, like, the actual device for other things, like, I don't know, smart devices that they created, then you can leave it on. But for our class, you can turn it off. Yeah, you can do that. It's just make sure that you have the fan on it, and then you can keep it running. Okay. So the case that comes with your kit has a fan, and you can just make sure that you adapt the fan. And the way that you plug in the fan, red is for the voltage, and then black is for the ground. So plug in the ground and then plug in the um, one of the pins for the volts. You can do 3.3. I think 5 will be a lot, but it will still work. Okay, so if you're using your Raspberry Pi for game console, like retro game console, you should have at least one fan. It's gonna run very hot. Okay, just to let you know. And then if it gets really hot, it crashes. So halfway through your game, it crashed and it doesn't save. So just make sure you have the proper cooling element. And for the micro SD card, does not come pre-installed, right? The one that comes with your kit, it does have the regular OS, the Raspbian OS installed, not the full version. I walk you through the full version. So if you use the one that comes with the kit, just plug it in and use, you have to update it and upgrade it. Okay. Okay. Any question? Okay, because I'm using my Raspberry Pi and the one I got is not turning on. Okay, so did you plug in your micro SD? Okay. And you put it in the right way, right? The pin facing the pin. Okay. Um you plug in the power cable. It should be turning on. You got it from the Cana kit? Okay. If it's okay, so sometimes it takes a little bit to set up the OS, but you should see something like on your screen, like some kind of Raspberry Pi interface. So if you don't see anything, possibly that the micro SD that you got didn't have any OS on it. So just follow the instruction in the assignment, exercise A, walks you through how to image it. So you can put the image on it. Okay? Yeah, likely that it's not, it doesn't have the OS on it. But when I checked the other day when I tested it, it has the old version of the OS that was released in November last year. Okay. Don't use the USB though. Take the micro SD out and slide it in its slot. If you're using the USB, it's not going to be able to read it. So yeah, don't use the USB on the Raspberry Pi. The adapter will not allow it to read the OS that way. Just to let you know. Okay? All right. Any question? So I have a little bit of time, so I kind of wanted to talk about what we're going to be doing tomorrow. It's not going to be too long tomorrow. Um, well, sort of. Okay, so for today we did RGB, we did LED, and then we wrapped up setting up Raspberry Pi. So you got the beginning part. Okay. And then for tomorrow, normally we would have 4 days, but since we have the holiday, I just want to extend every day by 15 minutes for 2 weeks. We should be able to cover some of it. For tomorrow, or in the lab, we are going to do an exercise using the buzzer, which is the piezo. Okay, so if you didn't take the Arduino class, there's some information about the buzzer. So piezo, it basically is a small speaker, and unlike your regular speaker at home or on your computer or in your car, it doesn't have an amplifier. Okay. And so it uses what's called a piezo crystal, and it's using this to really detect the amount of voltage that is applied. So if the shape changes, because when you apply voltage to it, it changes shape, and it's going to push against the diaphragm of the actual device. So it's gonna generate the pressure as in a wave, and that's what you're gonna hear as a pitchy noise coming from the buzzer. Okay. So inside here is the piezo crystal, and when it changes its shape, it's gonna push against the diaphragm of it, and it's gonna generate the sound that you hear. And so if you change the frequency of the voltage that you apply to it, it would change the sound that you can generate from it. So if you wanted to play a song from it, then simply you would change the frequency on it. Okay. And so for the voltage, it can grow and shrink as in the shape. And so over time, it would change. It could be fast or slow, depending how much voltage you give it. So if you really want to change its pitch, then you need to really control how the voltage is given to the piezo. Okay. And this type of component you're going to see in a lot of electronic toys for kids. Like if you go and buy a toy that makes like, noise, like, little musical sound, you're going to see some form of piezo in there. Okay. Very affordable. It would have 2 legs. Sometimes they come with 2 wires, red and black. Basically, it just indicate like positive and negative. so that way you can plug it in. So for the Raspberry Pi, you are going to use the GPIO. And so you need a breadboard, the buzzer, male to female jumper wire. You need to have the Raspberry Pi set up already, and then you got to give the Raspberry Pi power because it's going to supply the power to the speaker. Just like what we've been doing with the LED. Okay. The wiring for this is really simple. These piezo and other components, they are already resistors themselves built in. So you usually don't need any resistors adapted to your breadboard. Okay. So if you have the large one, you just gotta make sure that its leg is gonna line up with your wire. And then if you have the small one, just the same thing, but the larger one, it's harder to see as you plug it. And just make sure you have full contact to the breadboard. So the ground is going to be connected to the ground. There's many ground connection on the GPIO. And then for the positive side, you are going to connect to the pin. Okay. And the picture of that will look like this. So you see some of the speaker would have the wire come out of them. Some of them don't. Okay. So you are going to connect the positive pin to pin 11. And then for the ground, that's going to be ground pin 14. Okay, so let me close this. Then next, after you connect or you build your circuit, then you are going to install a library called Wiring Pi. Okay. It is a GPIO access library. It's written in C. And so the way that you install it, just like all the other ones, you would do sudo apt get install wiring. Okay. A few years ago, I was doing this exercise also, but there have been changes, of course, throughout time. Um, you you used to have to go and get this library from a GitHub account because it was not mainstream, and now they have made it mainstream. Okay, I have a question. I'm trying to download Raspberry Pi software into the USB, but I keep having the disruption error downloading. Send failure connection was reset. Did anyone experience this? So are you using the Raspberry Pi Imager, Jose?
Yes.
Okay, and it's giving you that. Possibly also because you're on Zoom with it. But yeah, let me see. When I did it the other day, I did it on 2 Pis actually when I tested it. I did it at night. So it might be that I think it might be either your internet connection, which might be the case because a lot of your bandwidth is on this session right now, or it could possibly be that sometime it could be their server, but that would be less possibility. Did anybody else have the same problem yesterday or? today? Okay. Yeah, Cynthia said no. But so that, okay. So Ghislaine, you said you have a different problem?
No, had. I
Okay.
thought, yeah, I thought it was not right. It was not writing to the micro SD
Oh,
card,
yeah.
but it ended up being like my power adapter. That was the issue.
Okay. Okay. So I think Jose, that might be something from connection wise. Like right now, bandwidth might be low across. For me, sometimes it is a little slow in the afternoon. So if you continue to have that problem, let me know. Um, I do have the full ISO downloaded. I can probably put it on my Google Drive and share it, but you still have to download it. So either way, right? So another way, I forgot to show you this because sometimes I have many things on my mind. And if you go to, let's see, if you search, you don't have to use the imager because sometimes the imager, I feel like it's slower. Okay. But the easiest way is to use the imager, but you can get the ISO directly from them. Okay. So if you visit this site, it tells you to use the um, imager, but if you go to see system images, you can find the ISO here. Okay, so this is the one that normally is recommended. That's like the regular version, and then you have the one with the desktop, and then the light is without the desktop. Okay, that's with terminal only. And then the Buster with Raspberry Pi desktop is the full version. Okay. And if you have torrent, you can probably pull it from torrent, but this is theirs. Okay. And then you can also find other OSs here. So this is the alternative way. In the past, what I did was I downloaded the ISO and then I use like DVD maker or CD maker or one of those software. The same thing with the imager, and then I had it transferred to, I use that to copy it to my SD card, and it works fine too. That's another way, but I think it's just a download issue with internet connection. Okay. Any other questions? So maybe try later on today when we get off Zoom. And it's okay if you turn it in a day or a few days late. I'm not going to have a big, as long as we wrap up the class at the end, we're fine with that. So don't worry if it's late. Okay, you still have the rest of the week. Okay, so since you don't have any other questions, and then we can attempt this tomorrow, but I just wanted to talk about it so that way you know what to do. So for this one, instead of like writing the whole entire script, we are going to use a GitHub or a Git that was created, which is the RPi example. And then we are going to put it in the folder, the directory. So ultimately, we are going to play the Star Wars song, right, Imperial March, with our buzzer. So if you were to program this, right, it's going to be very lengthy. Like I've done it with Sonic Pi, that it's super, super long. Okay. So I wanted to show you how you can use a repo, right, and then to be able to pull that down from your terminal and be able to do that. So once you hook it up, you're gonna do a git clone, and then you are gonna access the Star Wars example from that git clone, and then you are gonna run the file, which is Star Wars. Okay, and you should hear the song. Okay, so once you have that, you just take a picture of your circuit. The second thing we're gonna do tomorrow, we are gonna do Raspberry Pi server. This is a game server, Terraria. This is, you can, if you play it in the Linux, you can actually play it through the terminal, but it won't have all the graphics and stuff like that. Okay, so I've done this with several group of students, and they really like it. And so once you have it, you know, the server activated, your friend, when they come to your house, they can play it, right? As long as they put in the IP address for the Pi server, and downloaded the application. So you can run this on Windows or other system. So with this, there are quite a few steps on how you would set it up. And you don't need anything except for your Raspberry Pi and internet connection or network connection. Okay, so you would install Mono, okay, which is actually hosted with Ubuntu server. So you have to get a server key, and you're gonna use the HTTP port to be able to pull that. Okay, so what I did with these is I put the link on here for each one of them. The reason why I did that was when you run into commands that requires, you can type it in, but sometimes you might miss a letter or something, and then you run into like syntax problem. So you can go to the website, and then you can also copy and paste the command over, so that way it doesn't give you a lot of issues. And I found that would be really helpful to students. So so some of the steps that we're going to be doing is going to be installing Mono, and then before that we would have to get the key server, and what that does is going to be able to distribute key, and then the key server, then once it's added, then you are going to run Mono. Okay, now let's say a year from now and you want to do this project again, make sure that you change this right here to the current version of the Raspbian that you're using. Okay, because we're using Buster right now, so that's why it's working. But if you have a different version in here than the one that you're using, it's not going to work. Okay, so just FYI. All right, and then after we set up everything, then we would actually install Mono. After you have Mono installed, then you are going to download T-Shock. Okay, and then install T-Shock. So this allows you to have the executable for the game server. So once you have that, you would run it after you unzip it. And what that will do is going to open up, and it's going to ask you to create your world. I don't know if you're familiar with this game, but you can make a world, like a new world, and you would start with a small world and you can expand on it. You can use text-based commands to be able to navigate through in the terminal, or you can download their application and run it, and then you can have the graphic side of it. So you can connect to it using another computer, like your Windows desktop connected to your Pi and play it, or, you know, you can play it within the actual system itself. Okay, so I put down some of the commands that you can use, like in your terminal. So you can kick a player out, you can change your password, you can do a lot of the things as these are the command for T-Shock. Okay. And then there's a guide that you can get from Fandom, so you can pull some information if you like that. And that's basically what we're going to be doing tomorrow, uh, for the 2 hours. And then next week we'll do some other exercises with Raspberry Pi. Do you have any questions for me? Okay. I'll stay on for about till like 4:15 if you have questions. I'll let you get your work done. And so if you would like, you can type your name into the chat so I can manage attendance. And have a wonderful afternoon. And I will see you tomorrow.